Hello there! Welcome to the part 2 of our discussion on solving logarithmic equations and inequalities. This video is focused on understanding the basic properties of logarithms and the laws of logarithm. But before we proceed to this discussion, let us have first a review of what we have discussed in the part 1 of our video. Part 1 of our video is all about rewriting logarithms to its exponential forms. As a recap class, we have learned that logarithm is written in the form logarithm of a with base b equals c. In order for us to rewrite this logarithm to exponential, we must bear in mind that the variables or the values in our logarithm are also the values or the variables that can be found in our exponential. In our logarithm, we have the variables a, b, and c, and when we rewrite this one into exponential, the same variables are being used, however, they have different position. The base in our logarithm is actually the base of our exponential. The variable a in our logarithm is the answer to your exponential, and the answer to your logarithm is actually the exponent of your exponential. Please remember this discussion class because this will help you in solving logarithmic equations and inequalities. Now let us proceed to our next topic that would be all about the basic properties of logarithms. Our first property is all about one-to-one property of logarithm. According to this property, for logarithm in the form logarithm of a with base b, if a logarithm of u with base b is equal to the logarithm of v with base b, then u is equal to v. As what you have observed, our variable a has been replaced by the variables u and v. This means that we have two logarithmic expressions. We have the logarithm of u with base b and logarithm of v with base b, and they are separated by equal signs. But take note, class, that these two logarithms have the same base. They have the base b. So with this, we can say that one-to-one property means that if you solve two logarithmic expressions having the same or equal base, therefore, their values represented by u and v are also equal. To further discuss the definition, let us have an example. We have here the logarithm of 2x with base 4 equals the logarithm of 10 with base 4. Going back to the definition of one-to-one property, we can say that our base here is 4, the u represents 2x, and the v is represented by 10. Since we have logarithm with same base, therefore, we can simply disregard our logarithm base 4 and bring down 2x equals 10. So with this equation class, we can already identify the value of your x simply by dividing both sides by 2, and our x is equal to 5. Another example. We have the logarithm of the quantity 4 minus 5y with base 2 equals the logarithm of y plus 5 with base 2. Again, observe that our logarithm has the same base. Our base is 2. Since our base are equal, the bases are equal, therefore we can say that the quantity 4 minus 5y is equal to the quantity y plus 5. Since we are already on a linear equation, we can now solve for the value of y. Simply, we combine like terms. So we have negative 5y minus y plus 5 minus 4. Negative 5y minus y is equal to negative 6y, and 5 minus 4 is equal to 1. Divide both sides by negative 6 to extract y, so you will have y is equal to negative 1 over 6. So that is the example class on how we are going to solve logarithmic equations and inequalities with the use of our one-to-one property. Please take note that this one-to-one property is also applicable for logarithmic inequalities. Now let us go to the next property of logarithm. The second property states that the logarithm of 1 with base b is equal to 0. This property is also equivalent to the exponential property with a 0 exponent. If we try to rewrite this logarithm or this property into exponential form, for example, we have the logarithm of 1 with base 7 equals 0 is also equivalent into exponential, that is 7 raised to 0 equals 1. Another example, if you have the logarithm of 1 with base b, what would be the answer? So if we try to look at the second property of logarithm, you already know that the logarithm of 1 with base 3 is 0. Now let us go to the third property, that is all about the logarithm of b raised to x with base b is equal to x. As you can see, in our notation or in our property, the answer to your logarithm is actually the exponent of your b. Example, you have the logarithm of 3 raised to 4 with base 3 is equal to 4. Take note that your base is equal to the value of our a. Therefore, the exponent of our a is actually the answer to your logarithm. When you rewrite this one into its exponential form, you will have 3 raised to 4 is equal to 3 raised to 4. Another example, the logarithm of 81 with base 9 is actually the logarithm of 9 raised to 2 with base 9, and it is equal to 2. Now let us go to the fourth and the last property of our logarithm. And the fourth property states that b raised to a logarithm of x with base b is equal to x. As what you have observed, our logarithmic expression is being written in the exponent part of our property. This means that this property is in exponential form. Our property is in exponential form with an exponent that is written in logarithmic expression. And as what you have observed, the base for our exponential is the same or equal to the base of our logarithm. And the x variable in our logarithm is the answer to our property. Meaning, this fourth property states that if you have an exponential expression with an exponent that is in logarithm having the same basis, therefore the x value to your logarithm is the answer to your exponential. To describe further, let us have an example. You have here 5 raised to an exponent that is the logarithm of 2 with base 5. What would be the value of your x? If we try to rewrite this expression into logarithm, this would become the logarithm of x with base 5 equals the logarithm of 2 with base 5. As what you have see or observe, our logarithm has equal base, that is 5. And applying our one-to-one property, since same or equal, or their bases are same or equal, therefore x is equal to 2. So as what you have observed, our x here is equal to 2 and our 2 is similar to the x value of our logarithm, which is our exponent. So there you have it, class, the basic properties of logarithm. Now let us proceed to the last topic for this video, that is all about the laws of logarithm. First law state that the logarithm of u times v with base b is equal to the logarithm of u with base b plus the logarithm of v with base b. As what you have seen, class, our multiplication part for our u and v becomes addition. Your u is being separated from b and they are separated by an addition sign. Let us have an example. You have the logarithm of the quantity 3 times x with base 2. This would become, expanding using the first law, this would become the logarithm of 3 with base 2 plus the logarithm of x with base 2. So from multiplication going to division, we are expanding our logarithmic expression. Now let us have second example. Logarithm of 2 plus logarithm of 3. Take note, we are now using the addition sign. And using the laws of logarithm, since this is addition, condensing, we have the logarithm of 2 times 3 or equals logarithm of 6. Again, when you have the multiplication sign and you are going to apply the laws of logarithm, this becomes addition and the process is what you call expansion. But if you have the addition going to multiplication, the process is what you call as condensation. Now let us proceed. Second law. Second law states that the logarithm of u divided by v with base b is equal to the logarithm of u with base b minus logarithm of v with base b. Now this time we are using the division operation and expanding our division becomes subtraction. Example, the logarithm of x divided by 5 with base 3, expanding, class, this becomes the logarithm of x base 3 minus the logarithm of 5 base 3. Example, another example. You have the natural logarithm of x minus the natural logarithm of y. Observe that we are now already using the subtraction sign, so therefore we will condense our expression, and this becomes the logarithm of the quantity x divided by 5. Aside from the operation that we are using, class, in our second law, you should always observe, or you should be careful of what your numerator and your denominator is. Please remember that your numerator is your minuend in your subtraction part, and your denominator is your subtrahend in the subtraction part. This should not be interchanged, because when you interchange, it would already be another, this would be already be equal to another answer. Now let's proceed to our third property. Our third property states that the logarithm of the quantity u raised to an exponent n with base n is equal to n times the logarithm of u with base b. As what you have observed, our exponent in the expression becomes the numerical coefficient written before our logarithm. Example, you have the logarithm of 36 with base 5. If we follow our third law, this becomes, if we try to replace 36, this is already also equal to 6 squared. So you have the logarithm of 6 squared with base 5. Applying the third law, this becomes, bring down your exponent, write it before your logarithm, and write your logarithm, the remaining expression, logarithm of 6 with base 5. Now let us go to an example wherein we can apply the 3 laws of logarithm. I have here an example, the logarithm of the quantity 3 over x raised to the power of 3 with base 3. As what you have observed, class, our given is in the operation wherein we need to expand our logarithmic expression. So since we are going to expand our expression, meaning we will use for our division, we will use subtraction. For this exponent, we will use the law 3. So the law number 3 of our logarithm states that if you have an exponent, you bring it down and write it before your logarithm. So applying third law, this becomes 3 times the logarithm of the quantity 3 divided by x with base 3. Now in this part, you still have the division. So we will try to expand our division. So division is equal to subtraction in the law number 2. So this becomes, writing, we have 3 times the quantity logarithm 3 with base 3 from our numerator, minus, because we are having division, logarithm of x with base 3 from our denominator. Simplifying, class, we can have the logarithm of 3 with base 3 is equal to 1. Therefore, we can have 3 times the quantity of 1 minus the logarithm of x with base 3. Now let's go to our next example. Our next example is the logarithm of x squared with base 5 minus 3 times the logarithm of x with base 5. Take note that our given is in subtraction. So since this is subtraction, this means that we are on condensation. So first, we should apply our third law. The three numerical coefficient should be written as an exponent to your logarithm. So you have the logarithm of x squared with base 5 minus the logarithm of x cubed with base 5. Next step, since this is multiplication, we will rewrite this one into division because we are in condensing. So you will have copy the logarithm base 5, then x squared divided by x cubed. So you have x squared minus x cubed, x raised to negative 1, or you have the negative logarithm of x with base 5. So this is all for the second part of our video. Again, this part of our video focuses on basic properties of logarithm and the laws of logarithm. Like and subscribe to my channel for the next upcoming videos. Bye, class!